Colin Rosengren with Clean Seed Capital, the VP of Product Development. What we've got here in the CX6 is a new category, a new class of seeder. So we move beyond the air drill and the issues of the air delivery of product with distribution and challenges, I guess, of being able to control rates across a machine because of that delay in delivery and subsequent uneven distribution. So what we've done is move the metering back on top of every individual opener. So we've got 6 separate products in here, each controlled independently, and again, at each opener has its own 6 products delivered there. So that allows us to essentially meter in real time, gravity drop from here very gently and evenly distribute seed down the row as well as from row to row. Because it's metered at each one, it's accurate, it's the same rate. What it also enables us to do very simply is things like turn compensation and individual point shutoff. Because again, it's real time and individually controlled, we're able to change rates as it moves instantly, no matter whether it's predicted or not. We're also able to follow a prescription map at each individual row, so you can have different rates of different products across the machine.
Why did you bring the meters up off the openers then?
The meters up off the openers was done for a couple of reasons. One was to clean up our delivery lines. So at first we had a lot of extra hose on there. What this enabled us to do is run our hoses much more directly by keeping the meters solid and moving the openers up and down. So we've got some stretch tubes here that allow the seed to flow through. This is fully up right now. As soon as we get down into working range, there's a good flow through them and they stretch right out to the full range. So we're able to drop product through them, commonly used in other box drills and those type of things, planters. The other thing it enabled us to do was, again, with product switching. So any product can go anywhere, left side, right side, paired row, or down the point. Previously, when we were individually controlled, to change that, we had to change each opener. Now with the move up here, we've got all of product 6 on a common rail. So we simply can move it here in one location and change from going to the paired row to the left side only or down the point. We can simply change that position of a product in one spot and change the entire wing. So it simplified it. It makes the operation quicker for the farmer if he wants to change it. Less chance for error than if you have to go and move every individual opener of every product. So just simplifying things, I guess, and making some improvements and cleaning up the lines, cleaning up all that kind of stuff.
Okay. So this is also good for high rates of product if you want to.
Yeah, we've been able to push 350 pounds of nitrogen out of an individual opener. And then again, if you're going beyond that, in a single product again, because that's not fertilizer, you've got 6 product capability. So it's unlikely that you would want to put down more than that of a single product, because if you put your fertilizer in a blend, you probably don't have 5 other products. So even if you did that, you would probably use more than 1 tank. So if you want to use 2, if you're beyond that, then obviously you'd have the capability of going to 700 pounds. So the rates really, given the 6 products and that high of rate, is pretty broad to what you should be able to do. It shouldn't be limiting to anybody. The machine design is designed, we run on tracks for flotation, carries the weight of the entire cart, carries the weight of the entire machine. Through the turning axis of the machine here, so the pivot point of the tracks, the center of the tracks, runs through the center of the wings on the opener. So the side draft, the skewing, that type of thing is kept to a minimum. Everything follows that turn radius, so it turns very nicely in the ground and has good finish. The packers that follow out the back behind the turn radius actually pivot as well to follow that, so there's not side pushing of soil here. These guys simply turn and follow the path of that disc and have packing without pushing the soil sideways, leaving a good field finish even in sharp turns. The rear toolbar, which is offset from the pivot point of the machine, has a pivot itself up in there. So the rear toolbar can swing from side to side and follow, and the geometry is built such that we're not creating gaps and overlaps. When we pivot, it follows in the space between the wings while you turn.
So loaded, what kind of ground pressure do you have on this machine?
That would depend on how much weight goes on the openers, because the entire machine can be put, if we put maximum down pressure, we can essentially just about lift the tracks off the ground if we're on, pavement or hard conditions. So depending on how hard your soil is, what active down pressure you've got on your openers, we actually can have a very light footprint on these tracks. These are 100,000 pound tracks, so we're under that weight restriction, and like I said, once we transfer weight out to the openers, we should have a fairly light footprint in the field in the end.
This is where you fold it up, I guess, for transport?
Yes, it's a front folding toolbar. Without folding the machine here, I'll demonstrate, but it basically folds, the shoulders come back, and so it essentially folds like that and brings it in, tucks these guys in beside the machine, and allows you to travel down the road. We're not winging up real high or anything else. It just folds in beside it.
What's your transport width, height?
Right now, our height is 14 feet, I believe, when we do the axle lift, and the width is about 27 feet. So we are a little wider than we hope to be in the future. However, given that, the saving grace of that is a lot of machines with their width have the wheels positioned on the outside of that width. So if you try and pull off the road, you're dropping those wheels in the ditch and you can't pull over. Our tracks are centered on 11 feet, and so that allows us to actually pull over way towards the ditch and let that wing hang out in the ditch. So despite the wider width, when we're traveling down the road, we can pull over quite adequately to let traffic go by.
So is this, I know you guys have been doing some development, is this a production unit ready to go here kind of thing?
This is a production unit, yep. This machine is number 2 of 3 that are out there currently.
Okay.
Our product delivery system is a static system, so there's nozzles in the bottom of the tank, no moving parts. It's a central delivery system that they use on planters. We've got a few differences to it, but the essential basics of it is that when air is flowing through the machine and the screens are uncovered above the meters, the air velocity is such that it picks up product from here and starts blowing it. When it covers the screens, it basically just shuts it off. It back pressures the system, and product stops moving in the lines. Just like driving a grain truck down the road, when you get going fast enough, product starts to blow off. When you slow down, it stops. Very simple. Some of the challenges of those systems, handling multiple products and that type of thing with planters or different rates, you have to adjust that air pressure. It can be finicky to not plug lines and to get that shut off. What we've done and patented is we're running 2 blowers on the system. The second blower is running at a higher pressure than the first, and we're calling it our injectors. And so what we're doing is injecting a higher pressure of air after the nozzle than what there is before the nozzle. So when there's demand for product, the air flows through the nozzles and flows through that fan to supply the air and move the product. But when it starts to shut off, what happens is the injector system will pressurize the line, clear the line out, but shut off that nozzle prior to that. So it creates a very positive shut off and very low product buildup in the lines, and that gives us the flexibility to run the small seeds and the large seeds and everything together on the same system.
I see that's on every single tank, I guess.
Yeah, it's right across the whole thing. It's all the same. Again, all 6 tanks are the same in the bottom. There's no difference for small versus large versus anything else. It's common, and it works on everything from inoculants to chickpeas to any product can run through there. We can shut anyone off if we're not using tanks. We can simply block the airflow to them, shut them off, and leave them empty, so we don't lose that air.
Now, what kind of hydraulic flow do you need for the tractor?
Ideally, the higher systems will work nicer, especially with the transfer system, which we'll talk about in a bit. But we don't need high amounts. We can do things in the software to make it work. So essentially we need about 25 to 30 gallons to run the 2 blowers, and then we need probably about 5 gallons just for the active down pressure on the openers, just for the bleed off as it runs. So we're in that 30 to 35 gallons a minute, which is very low. I don't think we'd find a tractor that could pull it that wouldn't have that. So that's easy. We use about 50 gallons a minute to lift the openers, to do the opener up and down. Now, if you have a tractor at 60, which used to be common, what we'll do is put in the software to kill the fans when you demand to lift the openers. So we'll shut off the hydraulic oil to the fans, use the full flow to lift the openers, put them back in the ground, and then start the fans again. And again, because of the central fill system, it doesn't matter. You're not going to plug lines doing that. You've got a product reserve above the meter. So even if the meter does start before you had the openers fully in the ground, that's okay. It'll start up. You've got a little bit of reserve there, and then the fans will kick in and bring that product there, supply it very quickly. The transfer system is designed to use 60 gallons a minute for the transfer. So again, that's maximum flow we've designed in there. You can turn it down from there to what you have. The difference is it's going to take a little longer to transfer your product. So the more oil you put to it, the faster we can do the refill on the go system. So if you have more oil flow available, we'll use it. Again, we can shut that off when we go to lift the openers. So if you have that 80 or 90 gallons a minute, you can certainly run the blowers and the transfer system at full capacity. We'll shut something off when you want to lift the openers. If you have the maximum flow that's out on the new tractors, you don't have to shut anything off. You'll be able to run everything full out. The Smart Cart is new for us too, to support the logistics and handling of the CX6. So to facilitate getting 6 products to the field, we realized that was going to be a challenge for guys with semis. It means multiple trucks. It means a lot of logistical problems. So we developed the Smart Cart not only to fill on the go, but to handle that same amount of products and get it to the field where it's going to be needed, as well as making it a one-man operation. So the way this works is we've got a 5th wheel hitch underneath here, so you can hook up to your semi-tractor. Back up your semi, it's going to ramp up and lift this end up, so there's no fancy hydraulics or anything required to do the lift. It just ramps up the back of the truck when you back under. As you back under and ramp up, it's going to lift these floats off the ground, so they'll be up in the air. And then we run on the high-speed highway tires at the back with air brakes and the whole thing. There's also a 5th wheel plate at the back, so we're able to train them together. So you can hook 2 or 3 carts together and tow them with the same truck down the road. Matched 500 bushel capacity, same tank sizes as the main cart, so you can refill it. It's with the blower is mounted on the CX6 itself. So all we have to do here, there's no moving parts on this thing, there's no hydraulics to connect, none of that required. The air brakes, when you hook on, the brakes will be on while it's sitting in the field. Once you tie onto the CX6, you'll turn a valve to release the brakes so you can tow it. You'll turn a valve to release the pivots so that it can follow the ground contouring. And you also turn the valve on these guys to allow it to articulate in the field so that you can pull it and it becomes a wagon. When the truck hooks on again, you lock out those valves so that it's rigid and it's back to being a trailer. The hoses here, we've got one large 5-inch air supply hose. So this is our pressure hose that comes from the blower on the CX6 to supply the air pressure to this tank. After that, we've got all the different size lines here which are proportional to the size of the tank. So the largest tank has a 3-inch line to transfer product. The smallest tank has an 1.25-inch line to transfer product. All that does again is simply proportion the transfer time that it takes. So that each of those tanks, whether it's 30 bushels or 130 bushels, is still going to take about that 20-minute time to transfer. There's no use having one done in 2 minutes. All we've done to accomplish this is simply taper the bottoms. We've got a pipe that situates off to one side a slight bit, which allows airspace through the top of it so that they're not ever plugged or solid. There's room for it to get started, to get going. And then we taper down. So it's 3-inch supply, taper down to the size of line that we want to come out depending on that tank size again. It's a near dense phase pneumatic transfer system. So what that means is that the hoses move nearly full. So these hoses are at least 30% full of product. It's not a high speed transfer as you're used to with an air drill type of situation where you're sandblasting and you can't hold your hand in front of the hose and the product is moving fast. Dense phase is the opposite. It's a high pressure system that moves product very slowly in a denser hose. So it allows us to push product through these lines at slow speed, very gentle. You can put your hand in front of the discharge and it's simply the grain just falls down just as if you were dumping it out of a bucket. It's very gentle, moves product very quickly. It's low wear on the hoses when you move at that slow speed. And like I said, it's all proportional to move the entire tank at the same time.